Okay, example 4. Let's talk about what equivalent means and also equal. In this case, equivalent and equal are actually not the same in math, in set theory. So equivalent. So again, I'm looking at your handout. Again, right under cardinal number. And we know set A, right? It's in words. Set A is equivalent, right? So equivalent to set B means that A and B contain the same elements. So this is true, right? This means if and only if. So A and B, right, contain the same number of elements. Not the same elements, but the same number of elements. So, for example, if I gave you the set, I don't know, let's call it set V, capital V, and V is going to be, okay, in set builder notation, X such that X is a vowel. And B, let's actually say V, let's call it W. W is the set of X such that X belongs to a natural number and X is greater than or equal to 3 and less than or equal to 7. Okay, so the question is, are V and W equivalent? Meaning equivalent sets. Are they equivalent? Well, one way of determining this is, well, notice that this set is written in set builder notation, and this set is also in set builder notation, which I forgot to brace there. So I want to write it in a roster method. So roster method. So if we write V in roster method, well, that just says so all X, right, meaning they're probably talking about the alphabet, right, because we see vowel, X such that a certain restriction happens. X is a vowel. Well, if X is a vowel, well, the only vowels, well, I know in English are A, E, I, O, and U. Okay, this V is the same V as this V, right? The only difference is this is in set builder, right? And then here we have the roster method. So similarly, W is the set of all X such that X is a natural number. Now remember, the natural numbers are 1, 2, 3, and so forth. So 1, 2, 3, 4, 5, right? That means it keeps going. But specifically, right, my X, right, is greater than or equal to 3. So I know I'm going to start at 3. So natural numbers 3, 4, 5, 6, and I know I can stop at 7 because X is strictly, well, not strictly, but it's less than or it can equal 7. So I'm allowed to put 7 here, or equal to 3. That's why I'm allowed to put 3 here. And so that's what the set means. And notice I can draw an arrow between those, right? There's a one-to-one correspondence here. A goes with 3, E goes with 4, I goes with 5, O goes with 6, and U goes with 7, right? We can match them up. We can line them up. Now, what's the cardinality of V? Well, there's only 5 vowels, right? And what's the cardinality of W? And in this case, right, 3, 4, 5, 6, 7, there's only 5. So since the cardinality of V is equal to the cardinality of W, right, which is 5, then V and W are said to be equivalent, right, or equivalent sets, if you want to say. So that's how you determine if they're equivalent. And on your handout, right below equivalent, it says one-to-one correspondence and equivalent sets. So number 1, it says if A and B can be placed in a one-to-one correspondence. So let's see, let me make this maybe yellow. Okay, so they're here, my yellow little arrows. Okay, that's my one-to-one correspondence, right? You can line them up. If you can't line them up, then you know they're not equivalent. So that's pretty much it there. And then right below it, right, there says there are 2 ways to determine if 2 sets are not equivalent, right? And notice, right, method 1, I'll leave it in yellow, right? This is from your handout. Method 1 is, right, try to set up a one-to-one correspondence. That's more for visual learners. And method 2, right, is you can count the elements. And that's what we did when we said n of v was equal to n of w, right? We counted the elements and it was 5, but it's the same thing. Okay, so I'll stop here and I'll move on to the next video.